solve another Leetcode problem. 1034, coloring a border. This is a very good problem, but the description makes it really confusing. I think most of us cannot understand this part. Let me just explain it. Yeah, I think most of us cannot understand this part. So the border of a connected component is all the squares in the connected component. Yeah, so let me just explain it. So the border of a connected component. Let's just use this example. Yeah, I have to make another drawing maybe. Yeah, so we're gonna use this example. So here, this one in these areas, all the cell gonna be 1. So this whole areas will be a connected component. Yeah, I think we understand that. So this is gonna be a connected component, and the border of connected component is all the squares in the connected component. Yes, that is all the squares inside the component that are either adjacent to at least a square not in the component. Yeah, so it should be at least connected or adjacent to a square not in the component. So maybe this is because this is always 1. Maybe here is 2. Yeah, so in all those areas it's going to be 2. So for this one, this dot, it has a neighbor that is not inside the component, because at the right side it is 1, it is inside the component, but at the left side it is 2, it's not inside. So it means in the border areas, all those cells, yeah, should be our answer, because this is the first condition that are that either adjacent to a square, this is square 2, not inside the component, or the border of the grid. So where is the border? The border is this areas. Yeah. So this is gonna be the border. So after I make the drawing, I hope you understand it. And now the problem becomes the title. Yeah. Now the problem becomes title, coloring a border. We just want to color the border. We don't want to color anything else. So let's just continue. We just want to color these areas. So what color we want to do? So for example, at this connected component areas, it is 1, and outside it is 2. But what we want to color it to 3. Yeah. So this means in these areas, we want to, yeah, maybe let me use another color. Yeah. So in these areas, let me use red. So yeah. Yeah, so this means in these areas, we always wanted to color it to 3. So this is gonna be another color. So how can we solve it? Yeah, definitely we can use DFS or BFS to solve the problem, but I prefer to use DFS. So for the DFS, we can start from any point. So the position gonna be this row and column. Yeah. So if we are starting, so for example, if we are starting from here, so this is gonna be the row and column. So for example, we are starting here, and we're gonna use DFS to search the 4 directions. Yeah. So we're gonna continue to search until we go to the border, and then we're gonna color it until we go to this border, and then we're gonna color it. And after all those areas will be colored, but inside we will not color. Definitely DFS can solve the problem. Yeah. Now let's just continue to solve it. As I need to prepare some directions. Yeah. It's gonna be 4 directions. Let me search from the library. I think everyone have a library for coding. So for me, this is 4 directions. So I prefer to use the 4 directions. Let me copy some code from the 4 directions. So definitely, I need to prepare a row and column and 4 directions. Yeah. Now I also need a weighted set, because I need to record which position has already been visited, yeah, for my DFS. And then I'm gonna run the DFS with this row and column, and after that I'm gonna return the grid. Yeah, but I need to know the original position, original color. So for example, this is row 0 and column 0, the original color is 1. I need to know this original color, because after that, all those areas, all those ones will be colored to 3. But I need to know what is the original color. Otherwise, I will not know the connected component for all those ones. So I need to have a record of the original color. So let me use origin. So origin will be the original color. It's gonna be the grid row and column. Yeah. Now we are safe to start the DFS. So it's gonna be starting from R and C. So this is gonna be the starting position. Now I'm gonna check the 4 directions. So for DR, DC, inside of the directions, and let me update the 4 directions. It's gonna be row and column, R plus DR, and with C plus DC. And let me update the boundary of the row and column. Yeah. So if yeah, let me check. Let me first check the position. So for this RC, I have to check if it is not inside the weighted set. So I'm gonna go for the DFS. So otherwise, if I find a border or if I find another component, I will color it. Yeah. So I'm gonna check the row and column tuple. So if this is not inside the weighted set, so if it is not inside the weighted set, so this means definitely I want to put it inside. Yeah. But before I check if it is not inside, I have to check if it is inside the boundary or not. Yeah. So if row more than, yeah, let me just check it from here. Yeah. So if it is not inside the weighted set, I have to check if this row and column should be inside the boundary. Yeah, for the DFS. So if this row more than or equal to 0, less than R, and C column more than or equal to 0, less than the column. Yeah. So this means it is inside the boundary. And also for the DFS, I need to check if this grid row and column are equal to the origin. So this is my origin color here. Yeah. So if it is equal to the origin, so definitely I want to put it inside the weighted set. Yeah. So it's gonna be add this row and column tuple, and I'm gonna run the DFS for this row and column. Yeah. So this means if everything is just inside, everything is okay. So for here, just inside, I can go for the DFS until I go to the border. So where is the border? This area is gonna be the border. Yeah, so the border gonna be a else check. So if it is everything is inside the border, is every grid is equal to the origin color. So I'm going for the DFS. So if it is go out of the border, so for example, if this row equal to R, or row equal to -1, or column equal to C, or column equal to -1, it means it go out of the border. Definitely, I need to record this grid R and C to my color. So I'm gonna color it. Or is this grid row and column not equal to the origin? Yeah. So this is for here. So maybe I have a neighbor. It is a 2, not equal to 1, because my origin is 1. So I'm gonna color this one. This one is R and C. So I'm gonna color it to my color. So currently, this is I think this is all we need to solve this problem. Yeah. So definitely it is a DFS solution. And for the DFS solution, first of all, we're gonna check if this row and column inside the weighted set or not. So if it is inside, definitely we can do something. We can go for the DFS, or we can find the border. If we find the border, we're gonna color it. Now let me just run it to check. Yeah, as you can see, it works. Now let me submit it. As you can see, it works, and it passed all testing cases. And I think that's all for it. And the time complexity for such kind of problem, from here, it is basically it is a DFS inside a grid, so it is R times C for the time complexity, and M gonna be a very small value, so it is the time complexity gonna be M times N, because there's only one DFS, and in one DFS we just solve the problem, and I think this is gonna be the optimum solution for the problem. Thank you for watching. See you next time.